let's look at the fourth question of starter 72, that is n triplets. So this question says is Eliza is still not satisfied with Bob's math skills, so she gave him a new challenge. Given a positive integer n, find any three distinct positive integers a, b, c such that the product of any two of these three integers is a divisor of n. The product of all three integers is a multiple of n. If multiple solution exist, you may print any of them. Print -1 if no solution exists. Input format. The first line of input will contain a single integer t denoting the number of test cases. The first and only line of each test case contains a single integer n. So we have seen the input format of this question. So we only have to take input of n, that is our number, and we need to output or give output of three integers which are the divisors of n. So let's see how we can do this question. So let's clear this our whiteboard, and yeah. So we are given an integer. So we are given an integer n. We need to find three divisors of this integer such that a, b, c, let's name them as a, b, c. A, b, let's consider here there is a multiplication a, b, a multiplication b. I'll write it clearly, nicely. A multiplication b should also be a divisor of our n, and b multiplication c should also be our divisor of n, and a multiplication c should also be our divisor of n. So this is the basic condition that we are given. And then when we multiply all these numbers 1, a, b, and c, then the sum or the multiplication, the product should come as the multiple of n. We are given this condition, or we need to satisfy this condition anyhow, right? So let's take an example and understand this question more clearly. Let's take the test case only. So the first test case is 30. Let's take that. We are given n as 30, right? And we are also given that if the multiple test cases exist, then we can print them, and if not, then print -1. Okay, so we need to write the else condition also over here. So let's start with it. So we are given 30, and the output format here is 2, 3, 5. Okay, so let's understand with this. 2, 3, 5. When we multiply 2 with 3, we get 6, which is a divisor of 30. Yes, it is. Condition checked. When we multiply 3 with 5, it is 15. It divisor of 30. Yes. And when we multiply 5 into 2, so we get 10, which is divisor of 30. Of course it is. And when we multiply all these three numbers, 2 into 3 into 5, then we get it as 30, which is a multiple of 30. Yes, it is. So here the condition is satisfied. So how the approach we should have while doing this question is, there are multiple approaches, but we need to see the constraints also. So n is 10 to the power -9. So we need to take the greediest algorithm. We need to write the bestest solution to this question, because time it can go TLE, right? So let's consider, if I have a number n and I want to find its divisors, so I can find the least or the smallest divisor of it, isn't it? If I found the smallest divisor of it, then what I can do is n divided by that divisor, let's say a, n divided by a, then I will get the second one also, and 1 is the divisor of all numbers, isn't it? So 1 is always present, and when I multiply these two numbers, a and what I got as b, so if I write a into b into 1, so our b is n by a. So a into n by a into 1, and it would give us as n, and n is also a multiple of n, and it would almost satisfy our all the conditions. Let's check it via a example. Like, let's say we'll take 48, right? Let's take 48. If I want to find out the least number which is divisible by 48, prime number, least prime number which is divisible by 48, that is 2. 2 is divisible by 48. Then I will do this as 48 by 2, which gives me as 24, right? My a is 2, my b is 24, and my c is 1. C is constant. And when I multiply 2 and 24, I get 48, which is my which is divisible or divisor of 48. Yes, it is. 48 is a divisor of 48. When I multiply 24 with 1, I'll get 24, which is a divisor of 48. And when I multiply 2 with 1, I'll get 2, which is a divisor of 48. So all my conditions are being satisfied, isn't it? So our logic is done over here. This is how we would get three numbers, and yeah, that was the all question about. So let's try to code it. Right, I'll explain this code of this question. Let's go and let's see our code. So I I have I have taken input. I'm really sorry. So the whole code goes the same way. Over here, I have you on line number 11. I have used a for loop, and I am traversing the values till the square root of n. So why am I taking the square root of n over here? So the reason behind this is, if at all my number is not present, right? If at all my number given to me is prime, and that is a really very big number that I am given, and it is a prime number. So if I write n over there, then my whole for loop would be executed, and I will waste a lot of time, right? So I and at max, if a number is not if a number is a composite number, then it would get its prime factors by uh, the end it comes to its square rooted number, right? So to just to make my loop short, I have used square root over here, square root of n, and it gets you the answer every time. So yeah, for loop I have used, and the condition you can see over here. I am starting I with 2 because 1 is always there, right? So I'm starting our loop with 2, and 2 is the smallest prime number, I guess. Yeah. So yeah, we have written our for loop over here, and in 13th line I have given a if statement. If n modulo I is equals to 0, see out I space n I space n divided by I, as we have seen over here in the question, in the answer, right? The same thing we are doing over here, n divided by I and 1, and that's it. And after this we would return, because we don't want our loop to further execute, so we'll directly write return over here. And with this, our code ends over here, and thank you for watching.